Problem 9. You have L-shaped tiles, each consisting of 4 squares as shown. How many of the following shapes can you make by gluing together two of the given tiles? How many different shapes can we make by gluing two of these tiles together? Let's dive in. Let's grab two tiles and test our first option. Can we make this shape? Let's see. Like this or this? Yes, we can make this shape. So that works fine. Now let's check the second option. So we have this L shape and this L shape. Can we make it? Yes, we can make it. Now we move on to the third tiles. Can we make this shape? 1 and 2. Yes, we can make that too. So we can make 3 in altogether for now. Let's see the fourth one. We make here and here. It seems like we can make the fourth tile too. Look at that. So how many we can make in total? We can make all the 4 tiles to glue together. And our answer is option E, 4. Problem 10. Once little piggy planted 8 acorns. In a few years, oak trees grew from all acorns except 2 of them. All oak trees except 2 of them had their acorns. Acorns from all prolific trees except 1 are very tasty. How many oaks with tasty acorns are there? These are our options. All right, here's the story. Little piggy planted 8 acorns. But oh no, not all of them grow. So here are our 8 acorns. In a few years, oak tree grew from all acorns except 2 of them. So we removed 2 acorn trees. Now those acorns are changed into oak trees. So we have all these oak trees except 2 of them had their acorns. So all the oak trees except 2 of them have their acorns. So except 2, we cancel 2 of the trees. So we are left with 4 now. Acorns from all prolific trees except 1 are very tasty. So 1, we remove it. How many oaks with tasty acorns are there? We see 3. So we have 3 trees have delicious tasty acorns. Our answer is option B, 3. Problem 11. In a Sudoku, the numbers 1, 2, 3, 4 can occur only once in each column and once in each row. In the mathematical Sudoku, on the picture, Patrick first writes in the results of the calculations, then he completes the Sudoku. Which number will Patrick put in the gray cell? Alright, let's dive right in. First, Patrick writes in the results of the calculation from the puzzle. Let's go through them quickly. So 1 multiply 1 gives 1. 2 multiplied 2 gives us 4. 4 minus 1 gives us 3. 9 minus 7 gives us 2. 1 multiplied 3 gives us 3. 6 minus 3 gives us 3. 1 plus 3 gives us 4. 2 minus 1 gives us 1. 8 minus 7 gives us 1. And 6 minus 5 gives us 1. So this is what it's appear. With all these numbers filled in, now we have a Sudoku grid that follows the rule. The numbers 1, 2, 3, 4 must appear only once in each row and once in each column. And this is the rule. It's being written here. Now, look into the Sudoku and let's solve it. So we have 1, 2, 3, 4. Here we are missing 2. So let's bring up 2 in here. Now let's go on. See what's missing on this row. We are missing 2. Let's bring 2 in here. We are missing 4 on this column. We bring 4. We are missing 1, 2, 3, 4 in here. We are missing 2 in here. And in and, we know it is 3. So the gray cell is number 3, which is option C, 3. Problem 12. Grandmother made 20 gingerbread biscuits for her grandchildren. She decorated them with raisin and nuts. First, she decorated 15 biscuits with raisins and then 15 biscuits with nuts. At least how many biscuits were decorated both with raisins and nuts? These are our options. Grandma baked 20 biscuits in total. She decorated 15 biscuits with raisins. She also decorated 15 biscuits with nuts. Wait a second. There were only 20 gingerbread biscuits. That means some biscuits must have both raisins and nuts. To find out at least how many have both decorations, let's use a simple trick. If we count all the decorated biscuits separately, it looks like 15 plus 15 gives us 30. But there are only 20 biscuits. This means that the biscuits decorated twice with both raisins and nuts must be at least 15 plus 15 minus 20. That means 30 minus 20 gives us 10. So at least 10 biscuits both have raisins and nuts. And this is our answer, option E, 10. Problem 13. Among Nikolai's classmates, there are twice as many girls as there are boys. Which of the following numbers may be equal to the number of all children in this class? These are our options. Let's break it down step by step in a simple way. We are told that the number of girls is twice the number of boys. Let's say there are B boys. Now, since there are the twice as many girls as there are boys, that means we can make it the number of girls is twice of B. 2 multiply B means 2B. The total of number of students in the class is now is B for boys and 2B for the girls. That is B plus 2B. That is 1B plus 2B gives us 3B. This means that the total number of students must be multiple of 3. But Nikolai is also part of this class, meaning the total number of students is actually 1 more than a multiple of 3. So 3B excludes Nikolai. But 3B plus 1 gives us the total number of students in the class. We pick each options. So we say option A is 25 and we have to find out whether it's a multiple of 3. So we take out Nikolai out of it. So we say 25 minus 1 gives us 24. This is a multiple of 3. This could be our answer. But let's try option B. Option B is 20. That means 20 minus 1 gives us 19, not a multiple of 3. So that could not be our answer. Option C, 30. 30 minus 1, 29, not a multiple of 3, could not be our answer. Option D, 24. 24 minus 1 gives us 23, not a multiple of 3. Option E, 29. 29 minus 1, 28, not a multiple of 3, not an option. So our answer is option A, 25. So 25 is our answer. The total students are 25, including Nikolai. Problem 14. In the animal school, 3 kittens, 4 ducklings, 2 goslings, and several lambs are taking lessons. The teacher owl found out that all of her pupils have 44 legs altogether. How many lambs are among them? These are our options. Let's get into this problem step by step. So we have 3 kittens. Each kitten have 4 legs. That means how many total legs we have? 3 into 4 gives us 12 legs. 4 ducklings. Each duckling has 2 legs. So 4 duckling will have 4 into 2, 8 legs. 2 goslings. 2 goslings. Each gosling has 2 legs. That means 2 gosling will have 2 into 2, 4 legs. Now, total so far. 12 plus 8 plus 4 gives us 24 legs. Teacher found out there are 44 legs in here. So how many legs left? So we say 44 minus 24 gives us 20 legs. So the lamb has 20 legs. But each lamb has 4 legs. So we divide this 20 into 4 gives us 5 lambs. So question is how many lambs are among them? So there are 5 lambs among them. So our answer is option B, 5. Problem 15. In one kangaroo family, there is a custom to name their babies by names, which consist of 2 letters of the word kangaroo. The first letter is a consonant, the second letter is a vowel. How many different baby names can be composed? These are our options. Let's find out the consonants and vowels in kangaroo first. So we have C, we will represent as consonant, V as vowel. So we have C as consonant, V as vowel as A, consonant, and C consonant, G consonant. We have A as vowel, R as consonant, O as vowel, and vowel. Now let's count the consonants together. So we have 4 consonants, K, N, G, R, and that is 4. We have A, O as vowels, but they are double, so we count them as 1. So 1A, 1O gives us 2. In total, we have 8. So our answer is 8 different baby names can be composed, which is option A. Perfect. Let's move on to another problem. Problem 16 from original kangaroo paper. At a Christmas party, there was exactly 1 candlestick on each of the 15 tables. There were 6 5-branch candlesticks and the rest were 3 branched ones. How many candles had to be bought for all the candlesticks? These are our options. Let's get into this problem step by step. The first thing being said is that the total number of tables and candlesticks are 15. Then total 5-branch candlesticks are 6. So how many candles we can fit it in? 6 into 5 gives us 30. Then the remaining candlesticks, that is 15 minus 6, gives us 9. So 9 are left. Now it says the rest were 3 branched ones. So we say 9 into 3 gives us 27. So there were 27. So how many candles had to be bought for all the candlesticks? That means we sum 30 plus 27 gives us total candlesticks, that is 57. This is our option C. That wraps up the last problem of part B from 2012 Math Kangaroo for grade 3 and 4. Great job following along. We will see you in part C of 2012 for grade 3 and 4. Stay tuned and keep practicing. Happy mathing!